Okay, so welcome back, and now we're going to talk about, we're going to get to regular hexagons, but let's start by talking about a regular polygon. So a polygon, we know, is just a closed figure in a plane, right, that we talked about, that has three or more sides. Okay, that's it. Now a regular polygon, the word regular implies that it has some special characteristics. Those characteristics are that all the sides of the polygon are the same length and all of the interior angles of the polygon are the same measure. Okay, that's what we mean by regular. So a regular polygon meets those two conditions. Okay, now we've dealt with regular polygons already. For example, an equilateral triangle and a square are examples of regular polygons. Okay, so let's do some more. What about a pentagon? Right, so that has five sides, right? So if we have a pentagon, that's a five-sided figure. And if we have a regular pentagon, well, what does that look like? It looks something like this. Okay, where all of the sides are the same. Now in this case here, how do we get the measurements of the angles? Because in a square, the measurements of the angles are 90 degrees. In an equilateral triangle, they're 60 degrees. Well, in this case here, what do we have? Well, in this case here, if we draw lines from the center to each one of the vertices, each vertex, well, what happens? Well, we know that the angles on the inside here have to add up to 360 degrees. And since we know it's a regular polygon, each one of these central angles has to be the same. So there's 6 of them. So if we take 360 divided by 6, we get 60 degrees. Or excuse me, I'm sorry, 5. Sorry. There's 5 sides. So if I divide by 5, what do I get? Well, I get 6, right? So that's going to give me, oh, well, hold on. Oh, it is 60. I'm sorry. Oh, no. Come on, Mark. It's not 60. It's 63. No, not 63. 62. Oh no, I'm sorry, 72. That should be 75. And that should be 2. Don't know how to divide today. Okay, sorry about that. So, if I divide 5 into 360, I get 72 degrees. So the middle angles are all 72 degrees all the way around. That means, again, what do I just create here? This is an isosceles triangle because these two lengths are the same. So the base angles must be the same. So what's left over? Well, 172, so 180 minus 72 is 108. Well, if this angle here is the same as this angle here, well, then that should add up to 108. So that means each angle of the vertex is 108 degrees. Okay, now let's talk about hexagons. So what would a regular hexagon look like? Looks something like this. Okay, pretend it's a regular hexagon. So now if I draw a diagonal, now what I'm going to do is I'm going to draw a diagonal like so, right through the middle. Now I have 6 triangles. And again, the angle in the middle has to add up to 360. So now this is where I get 60 degrees, right? So this is going to be 36, 0, 0, okay? So each one of the interior angles is 60. Well, guess what? That means each one of these angles is also 60 degrees because it's an isosceles triangle. In fact, this is an equilateral triangle, as you can see. Which means that these angles here are 120 degrees on the inside, the vertex. The angle formed by the vertex is 120. Now, why is that important? Because we're going to find the formula for the area of a regular hexagon. Okay, so if I know that each one of these sides is A, right? Well, I already know the formula for an isosceles triangle, right? For an equilateral triangle, right? What's the formula for the equilateral triangle? Okay, for an equilateral triangle, the area was equal to what? It was b squared times the square root of 3 divided by 4, right? Well, guess what? How many triangles do I have? I have 6. This is the formula for just one of those equilateral triangles. Instead of B though, right, what's B? That was the B I used for base. Now it's going to be A. Right? So instead of B, they're using A. So if I look at this triangle, the base is A. So instead of using B, like I did in the previous video, I'm going to use A. Same thing. But now, I've got 6 of these. This is the formula for just one of those triangles. I've got 6 of them. So guess what? I'm going to multiply this by 6. Well, what do I get? This is divisible by 2, right? And the 2 divides this as well, so I get 3. And so my final formula is going to be 3a squared times the square root of 3 over 2. And that's the formula for the area of any regular hexagon. Have a great day.